Hi, welcome to Math Learning Hub, and this is Chanya, and this is a hub for everybody who loves math. Today we're going to be doing a brief overview of angles and discuss how angles work in regular polygons. So first of all, I'm sure that you all know what an angle is. So an angle is what is formed when two lines or rays intersect. So for example, if I have a line here and I have a line here, like that, then what would be formed here is an angle, right? So when you look at right angles, they're exactly 90 degrees. So if you have something here, and then you have another ray here, and suppose that there's a little square denoting the space between the two. So that basically means the angle is right. In other words, it's 90 degrees. If you have an acute angle, that's an angle that's less than 90 degrees. So that would look something like this. If you had two lines that were here, and this was the angle between them, that would be an acute angle. And an obtuse angle is one that is greater than 90 degrees. So obviously this angle, the first angle I drew here, would be an obtuse angle. So basically you can just look at, this is the 90-degree angle, and that's just a baseline to see if an angle is obtuse or acute. So moving on to complementary angles. So complementary angles add up to 90 degrees. So for example, if you had this angle here, this angle here, and you had, let's call this x, let's call this angle x, and you had this other angle right over here. Let's call the measure of this angle 90 minus x. So these two angles are complementary because when you sum them together, when you sum the measures of x plus 90 minus x, you get 90 degrees, right? You get 90 degrees. So that is what complementary angles are. Let me write that. So complementary. Now, on the other hand, you could also have what you call supplementary angles. So supplementary angles. This is when two angles add up to 180 degrees. So suppose you have an angle here. Let's call this angle y. And you have another angle here, right? Another angle here. Let's call this angle 180 minus y. So when you add the measures of these angles together, you get 180 degrees. And therefore, these angles are supplementary because their measures add up to 180 degrees. So I'll let you get a good look at what complementary and supplementary is. Okay, and moving on to straight angles. So straight angles are another type of angle. It's just basically the angle that is 180 degrees. So if I have a line here, and I have something like that, right? Something like that. The angle formed right here, that is a straight angle. It is 180 degrees. If you have a circle, and you have the center point right here, the angle in a circle, like the entire sum of the angles in a circle, is 360 degrees. And finally, just some good things to know. The 3 angles in a triangle add up to 180, and 4 angles in a quadrilateral add up to 360 degrees. So this is just a brief overview. So looking at this diagram here, this diagram that has angle A and angle B. So you see the sum of A and B is 180. So what types of angles would these two angles be in relation to each other? Pause the video and think about it, and then I'll give you the answer. If you're ready for the answer, then they are supplementary angles because they add up to 180 degrees. Now looking at the second diagram here, this is just another diagram that illustrates that sum of the angles in a circle is 360 degrees. The third diagram here illustrates how the 3 angles in a triangle add up to 180 degrees. And this fourth diagram here illustrates how in any quadrilateral, or I mean 4-sided figure, the sum of the angles is always 360 degrees. So having said that about angles, we can move on to polygons now. So today we're going to be talking about angles in a regular polygon, which means all the sides are equivalent and all the angles have equal measure. So first I'm going to go over what an exterior angle is and how to find the measurement of an exterior angle. So suppose you have something like a regular triangle that looks like this. So the triangle looks like that. So if you have your 3 equivalent angles here, 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 and here, if you extend these lines, for example, if you extend this line, then the angle formed right here, this is your exterior angle, right? It's the same as if you extend this line and you take the angle here, if you extend this line and you take the angle here. All of these angles are exterior angles. And given that this is a regular polygon, which means all sides are the same, all angles have the same measure, these three angles are also going to have equal measure. So the way to find it is basically when you know the sum of all exterior angles is always equal to 360 degrees. So since the sum of the exterior angles is equal to 360, the degree measurement of one exterior angle is 360 over the number of sides. So for example, for a triangle, so the sum of exterior angles that's basically 360 degrees. That's true for any polygon. And then for one exterior angle, that's 360 degrees divided by how many sides it has, which is 3, which is basically 120 degrees. So that's the measure of whatever is here. So moving on to interior angles. So the sum of the interior angles is equal to n minus 2 times 180 degrees, where n is the number of sides. So the interior angles in this polygon, which is a triangle, is going to be the green angles. They're always going to be the angles on the inside of the polygon formed when the sides of the polygon join together. So in this case, the sum of the interior angles is, when you say n minus 2 times 180, your n is 3 because you have 3 sides. So it's basically 3 minus 2 times 180, which is equal to 180 degrees. And then to find just one interior angle, you can take the sum of the interior angles and divide it by the number of sides. So for instance, that would just be 180 over 3, which is 60 degrees for one interior angle. Let me write the process. So 180 degrees over 3 is equal to 60 degrees. An alternate way is that you could just take whatever exterior angle you have over here, and you take 180 minus that exterior angle. That is just a little diagram showing you. And that should be it. But before I end this video, I would like to show you how you derive this formula for the sum of the interior angles, which is n minus 2 times 180. And I'm going to try to get this formula or come up with it using a regular pentagon, for instance. Using a regular pentagon. So this is the pentagon in which all the sides are equal and all the angles have equal measure. So I'm going to start at one vertice. I'm going to pick this vertice and start here. And I'm going to break this pentagon up into triangles. So what I mean by this is I'm going to draw basically imaginary lines to each of the other vertices, just like that. So you can see now that the pentagon has been broken up into basically 3 triangles. Now, knowing the fact that the sum of the interior angles of a triangle is 180 degrees, the sum of the interior angles of this pentagon should just be the number of triangles you formed times the sum of the interior angles of the triangle, which is 180 degrees, right? It's the number of triangles you formed times 180 degrees. But how many triangles do you form in a polygon? Well, if you have n sides, you basically form n minus 2 triangles, right? So your number of triangles is n minus 2, and you have 180 degrees and each triangle. So therefore, this is the sum of the interior angles, n minus 2 times 180. So this should be it for this lesson. If you have any questions, then feel free to comment, and thank you all for listening to my video today. If you want more content like this, then be sure to subscribe to Math Learning Hub for more. And see you in the next video, guys. Bye!